Hello, good day to TS Dr. Zulia Azura and TS Dr. Muhammad Azri. So my name is Shannon Robin. Our group will present on our group project, which the title is the control process of heat exchanger at UTSM biodiesel plant. So overall, this project is focused on the proposing the new control system for heat exchanger in the UTSM biodiesel plant. Before that, I would like to introduce my group members, which is first is Nuh Amirul bin Rahman, and then Muhammad Syahrul Nizam bin Muhammad Taib, and then Muhammad Zahid bin Omar, and last but not least is Rishi Vaman Mani. So I will do the introduction part.
Yeah.
So for the introductions, biodiesel is a clean burning alternative fuel for diesels. And then this biodiesel is simple to use, it is biodegradable, and it is non-toxic. So in UTSM, we have one pilot plant which is in campus Pariraja, our main campus. And then this pilot plant is mainly the module is for CPO, which is stand for crude palm oil pre-treatment, which converts the CPO into the bleached palm oil BPO. And then the process that occurs in the UTSM pilot plant is refining and separating, which converts and process the BPO, the bleached palm oil, into the end product, which is biodiesel. So this is the block flow diagrams of biodiesel productions. So as you can see it is divided into two sections, which is CPO pre-treatment, and then the methanol recovery and the refining and separating. So the final product will be biodiesels. So for this project is first is to recognize the process control systems of UTSM biodiesel plants. Secondly is to identify input and output of process. Thirdly is to understand the concept of working flow of pre-treatment of these biodiesel plants. And finally is to propose and design new method for the process control systems of UTSM biodiesel plants. So in our project, we will focus on the heat exchanger process control systems. And that's all for me. I will pass it to my group members. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Nama saya Nur Amirul bin Rahman. I will continue our video report today. Okay, I will talk about plant control process review. Okay, in plant control process review, we have two types of control, which is feedback and feed forward. Okay, for our project, we use the feedback system control. The control is used to control the heat exchanger. Okay, dia punya system that process signal process. Okay, ranging from a very simple to a highly complex circuit. All part of the output signal, either positive or negative, is feedback to the input. Okay, output signal is sampled and then feedback to the input to form an error signal that drive the system. Okay, for our project we use heat exchanger. Okay, the heat exchanger system is prone to three major disturbances, which is changes in process fluid flow rate, changes in process fluid inlet temperature, and lastly change in steam pressure, causing a change in a steam flow rate. Okay, next, the mechanism of the work system. Okay, the outlet fluid will be detected by the flow element. Any disturbance that does not compatible to the desired set output will be detected and send control signal to the looping system. The control signal is received by the loop system, which will trigger the temperature element TE102 and temperature indicator control TIC302. Okay, TIC302 will compare the desired output with the process output. The sensor will detect any disturbance and send control signal to the control valve TV102 to take any action required. Okay, TV102 will be automatically closed or open depending on the signal sent by the sensor. Okay, that's all from my present. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Syahrul Nizam bin Muhammad Taib. So I will continue the presentation about the advantage and disadvantage. So the advantage of this project, this title is the system is the system is quite simple, and the controller will take the corrective action. The third is many unnecessary disturbance and noise signal from outside the system can be rejected. And the fourth is the steady state error of system can be relatively small. So the disadvantage is incapacity to respond to disturbance. The overall gain of the system is reduced and must be compensated for in the design. So the third is the systems may not be stable. So this is the advantage for the system. So can we see this? This is example for the associate components along the process in the line, such as butterfly, temperature elements, and temperature indicator control, and lastly is check bus. For this process, they have a lot of the components, but this is for example.
Hello, now I will present about the alternative control system for heat exchanger. Okay, first the shell side fluid is the process fluid that is required to be heated to a certain temperature set point. Which is we set the temperature and then the fluid will be heated to the set temperature. Then the resulting temperature is measured at the outlet of the heat exchanger. So heating is achieved by passing steam through the tube side. So it flow through the tube and transfer the heat. So next, the more steam passing through the tubes, the more heat is transferred to the process fluid and vice versa. Okay. So control of the steam flow in F2 pipe F2 is achieved by throttling a modulating valve installed on the steam inlet side. So what is the integrated approach here is we have to maintain fluid outlet temperature at the desired set point, and alternate control system is proposed. So next we combine the feedback, feed-forward and cascade control system information so that we capable of accommodating heat exchanger control requirement. That is techniques to optimize heat exchanger temperature control. Heat exchanger temperature control is necessary. It's to minimize process variance, maximize product quality and ensure energy efficiency. So there is some of the figure for the control system in heat exchanger. We have here feedback control system of a heat exchanger, cascade control system in heat exchanger, and feed forward control system in heat exchanger.
So to be conclude, we are using feedback type control system in the heat exchanger of Hitachi biodiesel plant, which compare the process variable with the desired temperature set point. Then it immediately calculate and generate the control action to be done by the control valve, either to be open or closed. So regardless of the disturbance source, the controller will take corrective action as the advantage of this control system. And if too many disturbances occur at once with significant magnitude, they can create unrecoverable process instability. To prevent that process due to late response to disturbance, an integrated approach which combines feedback, feed-forward and cascade control system should be introduced. Combining the three techniques enable user to optimize heat exchanger temperature control and minimize process variance, and also maximize product quality and ensure energy efficiency. Thank you.